Our world is running out of fresh water, but the planet is covered with salt water, so can we just tap the seas with desalination and use that as a solution? Desalination today is a $10 billion global business with double-digit growth, but all of these competitors are using technologies, decades-old technologies, with the same problems of extreme energy use, which is expensive, and environmentally damaging brine discharge. We're SeaChange Technologies, and we solve both of these problems. Our novel mechanical approach to cleaning water is flexible, and we're able to desalinate seawater to the most saturated industrial brines, and we do it with low energy to produce pure water and zero liquid discharge. Our business model, our vision, is to produce clean water for humanity. To get there as a bootstrapping startup is hard. We're starting out producing a solution for an industry that is struggling to dispose of massive quantities of brine waste, and that's US oil and gas producers. In the US, there's 8 barrels of saturated brine produced with every barrel of oil, and the current method of disposal is expensive and controversial underground injection or evaporation ponds like this. SeaChange Technologies, for a fraction of the cost, can transform that into clean water. I had the idea about 2 years ago, and it's a mechanical approach. We take dirty water, aerosolize it mechanically, and then subject that to low air pressure and pull that through a cyclonic separator to leave the contaminants behind and pull out clean water vapor. By combining these simple, proven mechanical technologies, we transform the difficult water cleaning problem into a much easier air cleaning problem. And that's going to revolutionize the process. We've made a lot of progress in that 2 years. I have a dedicated team with experience in research and development, engineering, business, and dedicated advisors with experience in a number of international industries. And we're gaining attention among our customers, starting with the UT Energy Institute competition earlier this year, where we took first place. And we've just been accepted into a clean tech-focused startup accelerator program backed by Cherokee Fund. Our funding plan, we're on our way. We're still bootstrapping, but we've used those funds to produce our proof of concept mobile device, which we're taking around to show to customers what we can really do. And we can produce water from nasty sources that you would actually want to drink. I'd like to leave you with just one thought. Our world is running out of water, and business as usual is not solving the problem. We need something revolutionary. We need SeaChange. Thank you.
Okay, question. So I missed it. You said you move it from a water cleaning problem to an air cleaning problem, which makes sense, but then how do you clean the air? So what's your air cleaning process?
We use a cyclonic separator. It's similar to what you'd find in your Dyson vacuum cleaner. And because we're operating with high humidity, which is low density, and under vacuum, it works very efficiently. And we separate out salt, minerals, dust, metals, bacteria. Anything that's in there is coming out.
What capacity are you currently able to handle? How many gallons of water?
Well, our prototype, like I said, we're bootstrapping, so most of those components were purchased from eBay and Craigslist and whatever I could get my hands on. So it's not that much. It's maybe like 1 to 2 liters per minute. But we're making plans now and working with an actual industrial machine builder to build something that'll be robust and industry ready. And I'm talking with oil and gas producers to get pilot sites rolling next year.
What do you expect to be able to handle with your pilot demonstration?
Well, a gallon per minute is the minimum for entry, and that's a tough question because we're trying to figure out how much money we've got to build. Ideally, we'd like to do a barrel per minute. It's going to be more expensive to build that device then. So we're looking for co-development partners as well, if you know some.
What are your main challenge for scaling up and basically going to market?
Well, the initial units that we build are going to be one-off, and we'll work closely with our customers to develop solutions that will work on their sites for their needs. As we scale, though, we envision mass-producing modules that we'll be able to do at much lower cost than thermal or RO or membrane-based systems, with hopefully price them with a payback of 1 to 2 years.
You mentioned slow energy. What kind of energy requirements do you have? Is it, and what form of energy? Is it heat or electricity?
Currently, it's electricity we're using now. Based on our engineering contract evaluation, we believe we can use, for seawater, about half the energy required by RO. For the saturated brines, existing desalination technologies just can't touch them. So it's not really an energy equation, but comparing the cost of with their current solution.
Do you have a salinity limit
No.
before you start clogging up your aerosol, your
We
chambers?
we could put mud into this system and extract the water out of it. No pretreatment.
Have you tried that?
We
with
put some
mud?
pretty dirty water through here, yeah.
Okay.
Muck straight out of North Carolina's intercoastal waterway.
Okay.
Okay, final question?
I think you may have mentioned this, but what specifically are the byproducts that you end up with once it goes through your process?
Oh, depends on the water that comes in to start out with. So with oil field produced brine, it's going to be highly variable, but we're hoping to extract those minerals and metals as well.
Well done.
Thank you.